The research paper by Drewfs and Patricia Hill asserts that mass information intelligent agents embedded in the fabric of space-time derive physical laws and control this universe. The researchers further suggest that these higher-order mass information intelligent agents are conscious, self-aware, and instantiate human consciousness. Their paper traces the origin of the universe from a single mass in a vacuum, the white dot in the central circle, to the cosmos of today. They describe how that first positively charged mass demands a negatively charged counterpart in extra dimensions, the lower white dot in the far right circle with blue gravitational radiation arrows. That negatively charged mass mandates yet another, a positively charged mass in extra dimensions, the upper white dot with red gravitational radiation arrows. The result is the multidimensional pre-universe depicted here. Shown are the first masses, which differentiate into 5 positive and 5 negative charged masses in the cis space and extra dimensions. Why differentiate? The wall containing the sixth and extra dimensional spaces repels the masses as they pull on each other. Why 5 positively and 5 negatively charged masses? 5 is a prime number with fundamental congruences that naturally evokes division. That makes the division of masses into 5 of each sign likely. According to Drewfs and Hill, the first masses radiate continuous gravitational energy waves spanning the 2D vacuum cis space, the 3D extra dimensions, and the 3D bulk regions in between. That's because gravitational wave radiation knows no dimensional bounds. The researchers detail how dark energy particle pairs are created by the mandatory interaction of oppositely signed gravitational waves radiated by the first masses. They describe how dark energy constitutes the weave of space-time indicated here by the yellow dots. Dark energy, like gravitational radiation, soon permeates the entirety of the classic cis space and extra dimensions. Drewfs and Hill argue that the result is dark energy quantized Minkowski space-time, but with gravitational cones in place of light cones. That makes the flat cis space the observer relative present, the lower extra dimensions the past, and the upper extra dimensions the future. The researchers claim that the flow of gravitational waves creates 3-dimensional membranes, indicated here by the torus of thin yellow lines. These membranes stream about every mass. The membranes they call bands are composed of positively charged graviton and negatively charged gravitino-wave particles. The particles are created by dark energy slicing the continuous gravitational waves into quanta. Hence, as indicated on the right, the probability of finding the graviton or gravitino approaches 0 as the gravitational wave particles near our classic space-time, but go to maximum in extra dimensions. Drewfs and Hill posit that in the ultra-cold pre-universe, the churning waves with gravitons form positively charged Bose-Einstein condensates the solid red circle. The gravitinos form negatively charged Fermi condensates the solid blue circle. Mandatory bidirectional interactions between the condensates produce superpartner wave-particle pairs, primordial dark matter, indicated by the central red and blue swirls. Each vibrating waveform string of the condensates constitutes a 10-bit classic word and 1703 quantum qubit word, where qubit is the quantum analog of a classic bit of math information. Each condensate interaction transfers a portion of the condensate's mass energy to its superpartner particle product. Each superpartner is a vector composed of positive bosons red and negative fermitons blue, all bridged and braided together by anyon particles, the white dots between the bosons and fermitons. Anyons produce the flux tube, the depicted green sheath, that holds the vector together and entangles the bosons and fermitons. Without the anyons, the bosons would clump and fermitons would seek independent states. Thanks to the anyons, each superpartner vector constitutes an 11,703 qubit word. The investigators assert that the entangled superpartner vector pairs develop into intelligent quantum neural networks. These are naturally occurring, self-organizing, self-learning, and self-supervising competitive filter networks. The type of network well described in the prevailing literature. The researchers call these super-partner quantum neural networks SPQN. SPQN output their population distribution function and topologically map their boson and fermion particle distribution, indicated by the bell curve on the right. SPQN are very smart, but wholly unaware of what they are doing. Drewfs and Hill suggest that the SPQN in the cis space and extra dimensions communicate via a gravitational wave membrane circulating around and through all space. These gravitational interactions give the SPQN a sense of time, called Minkowski time-space. That helps the SPQN learn to characterize past, present, and future information states, indicated here by the yellow line and circulating white arrows. The investigators posit that the SPQN are the preprocessors for the true mass information intelligent agents of the universe, intelligent agents that are conscious, aware, perceptive, effectively active, and cognitively functional. The researchers cite literature asserting that dark energy interacts with the early masses through wave-borne particle density perturbations, the smudges in the central circle. All matter perturbs the density and degree of entanglement of the dark energy field, the very mesh of space-time. Those perturbations constitute dark energy holographic quantum neural networks, associative memories that map the mass information content and context of all matter events in dark energy. These associative memories value weight and relate dark matter mass information inputs to dark energy field response outputs. The investigators found such intelligent networks well described in the prevailing literature. Here matter, the red sphere and yellow Drewfs, exerts a positive pressure on the dark energy particle field, the concentric circles with red border below. In response, the dark energy field imposes a negative pressure on matter and its enshrouding gravitational membrane. These interactions result in a progression of holographic dark energy reactions, as indicated by the stack of holograms in the far right corner. Dark energy reacts like a superfluid, its wave response spreading like ripples on the surface of a lake. That creates an abstracting progression of holographic ring images that characterize each matter wave particle event. Dark energy spreading wave reactions to dark matter give rise to a hierarchy of increasingly abstract mass information, indicated by the white arrow pointing up the stack of holograms. Moving down the hierarchy, dark energy responses become increasingly specific, indicated by the white arrow pointing down on the stack of holograms. In between, the intelligent hierarchy of quantum neural networks weights inputs, associates previously learned patterns, and publishes reactions in ever-tightening detail. These processes characterize what Drewfs and Hill call the holographic chameleon quantum neural network of networks, HCQN. The term chameleon indicates the HCQN dynamically adapts its mass density relative to the proximity of matter and is self-interacting. Drewfs and Hill assert that these HCQN are fully connected, operate faster than light, and are composed of dark energy particle pairs. Each dark energy particle pair is a complete holographic quantum neural network possessing a 3,406-qubit processing and storage capacity. The team cites sources that estimate there are 10 to the 66th power entangled particle pairs per cubic centimeter of universe. Human beings in contrast have 10 to the 12th power switch connections per cubic centimeter of neural tissue, process information relatively slowly, and are correlation error biased. HCQN and mass information intelligent agents have no such bias, owing to their holographic structure. The investigators argue that the Big Bang expansion of the universe resulted from the concentration of mass information and energy in the entangled super-partner particle pairs. The pairwise entanglement build-up is depicted at the bottom left of this figure. The entangled super-partners create massive virtual super-partners in the sixth space and extra dimensions, the first concentration of mass since the dark energy quantization of space. The pre-universe collapses under its own weight. The dark energy HCQN agents recoil in response, thus enforcing the conservation of mass, energy, and information. That recoil produces the Big Bang expansion that continues today. The expansion of space occurs faster than the speed of light. Hence, the dark energy HCQN literally outrun the thermodynamics of the Big Bang. The expanding superpartners birth the particles of modern dark matter and the quantum standard model within the first 20 minutes following the Big Bang. Then the cosmic dark ages last until 100 million years after the Big Bang. The team argues the cosmic dark age is just the time needed by the mass information intelligent agents to learn the new forms of matter, their interactions, and the physical laws needed to govern them. The figure illustrates the researchers' assertion that HCQN intelligent agents enforce physical laws from the smallest wave particle to the edge of the event horizon of this universe. Red circles depict the aggregating levels of gravitational radiation membranes dividing the universe in levels of scale. The left side of the figure lists the characteristics of such gravitational membranes as described by physicist Lisa Randall in 2005. The numbers in the circles and on the right defines these divisions of the universe. Prior research placed a size limit on extra dimensions at less than or equal to 10 billionths of a billionth of a meter. Drewfs and Hill hypothesize that these size-constrained extra dimensions form bubbles, like that shown in the lower left corner. The bubbles turn the dark energy field into a kind of foam that petitions the intelligent fabric of the universe. Thus, the foam groups HCQN and intelligent agents into micro-mini Minkowski spaces, each having its own present, past, and future. These are the space-times in which the entangled hierarchy of mass information intelligent agents source and enforce physical laws. Drewfs and Hill assert that each dark matter and ordinary matter particle exists, moves, and interacts within a gravitational bubble, depicted by the yellow line torus at the bottom of the figure. The extra dimensions in each bubble are less than 10 to the -16th centimeter. Thus, each wave-particle universe has its own local hierarchy of HCQN and mass information intelligent agents. But, due to entanglement, those agents are fully connected to the regional, global, and universal HCQN networks. Why does this matter to us? Drewfs and Hill assert that we humans are most likely connected to those mass information intelligent agents. Since 1995, Roger Penrose and Stuart Roth have continued to gain evidence supporting their orchestrated objective reduction model of consciousness. Their model claims that when hyperneuron populations reach a critical mass, the pre-conscious quantum wave state collapses and gives rise to conscious awareness in our brains. Drewfs and Hill suggest that the binding of consciousness model describes the human connection to the dark energy hierarchy of mass information intelligent agents. Here's how. Every 30 to 70 seconds 1 billion bubble universes occupy the alpha and beta proteins of the microtubule filaments comprising the axons of our neuron cells. That triggers the quantum waveform collapse in our neurology, instancing consciousness in us. All this is still speculative, but likely. How much influence might these universal mass information intelligent agents have over us? What we perceive as ourselves is likely no more than 5% of every neural cycle. The other 95% is likely the work of universal mass information intelligent agents.